On the bench today is a early 60s Scott kit. It's the LK-48B version, which is equivalent to the Scott 222D, which was the pre-assembled version. This belongs to a friend of mine, and he's asked me to refurbish it. So we're gonna do that in this video. A great resource is available on Blueglow Electronics' YouTube channel. He has some great videos. He actually does a full restoration on the 222C version, which is the predecessor of this one. So we are going to, or I am going to, replace the caps, the capacitors. I've already removed the bottom panel. I'll show you that in a moment. And I haven't replaced any yet, but I have tested them, at least the ones that I could test in circuit. And you know, this thing is 60 plus years old now, so we're just going to replace all of the electrolytics, all of the film caps, and a few other parts and pieces. I actually bought a kit from an outfit called HiFiAudio.com, and it includes all the capacitors and other parts that are worth changing. I have to think about how I'm going to do these big electrolytic cans. I don't think I really want to tackle trying to open them up and stuff capacitors inside. So hopefully there's room under the bottom where I can just remove those from the circuit and then wire in the equivalent. So we're going to replace the caps. There's a rectifier in here, a selenium rectifier. We'll replace that. Let me go ahead and turn it over and show you the other side. I flipped it over. I had already removed the bottom panel, and you can get an appreciation for the beauty of the point-to-point wiring in this thing. The buddy of mine, this actually was built by his dad. And as near as I can tell, it looks like he did a good job. I will go over all of the wiring and make sure there aren't any solder joints that have gotten flaky. Like I said, we're going to replace most all of these capacitors and this selenium rectifier that's buried back in there. We'll get a closer look at that when we get to it. There's also a broken front panel switch. Let's see, this guy right here lost its little switch knob. I was able to locate on eBay a replacement panel for that. Let me show you that here. So this is just basically the sub panel with the switches, and I should be able to get what I need off of there and fix that switch. We will of course clean all of the controls and switches with deoxit. We'll do that. I'll clean the tube sockets with some deoxit. All of the panel connectors, we'll clean those. And then once we get that all done, we'll power it up. We'll power it up on a variac and a dim bulb and make sure everything is copacetic. The bias adjustments and all that stuff we'll do once we get it up and running. One of the nice things in buying the kit from HiFiAudio.com is he includes a lot of files, including the assembly manual, which is going to be handy to have. I mean, this was quite the process in the day, but it goes through step by step where everything goes, how to wire, what color the wires are. So that should make it relatively easier for me as I swap out capacitors to make sure I don't mess up anything. He also includes his own guide. To restore the thing, and that basically goes through what's included in the kit. So starting with the power capacitors, that's the big ones, and then leading up through all the other various components. So I'll be following this as well, and hopefully this will be a video that might help somebody in the future who's restoring something like this. He also includes the schematic, which will be pretty handy to have. I've already started sketching out to replace those big electrolytics where the various wires go. I'm going to start by replacing the big electrolytics here. This is C203. Underneath these wires here is C202, and over here is C201. And I don't think I'm going to try to pull these and put the replacement capacitors in those cans. I think it'll be easier, and I think there's space for me to remove these connections, put in the new capacitors, which are right here are the new capacitors, and it should fit. So we'll do those first. I already sketched out which connections go where, so we'll be able to hopefully put everything back where it was. Before I start working on the chassis underneath with the capacitors, I'm going to go ahead and remove the tubes, put them in a safe place. I'm also going to remove the front panel knobs and that front panel plate, because I know I'm going to need to get behind there in a while, so let me do that now. I removed this front panel cover plate, so I'll be able to get access to the switches back here. Also did a little bit of cleanup on the chassis, and now I'm ready to start replacing these electrolytic caps. Again, I'm going to just replace them from underneath rather than try to pull these and remount. So I'm going to start with C202, which is the 100 4 times 100 microfarad, and I'll build that, and we'll flip this over and start replacing some of these caps. I flipped the amp back upside down again, and like I said, I'm going to start with C202. So I've assembled these 400 microfarad at 100 volt capacitors together, tying the positive leads together because this is a positive can, and my plan is to install that right here. There's space, and then I'll move these 18 ohm resistors from the bottom of the old can onto my new assembly, and hopefully that'll fit in there. There's the finished capacitor for C202. I've got the 18 ohm resistors mounted around the outside. I just put the 4 cans. Fortunately, they're pretty short, so it should fit in there just like that, upside down. I'm not going to glue it down until I get the rest of these done, so I have a little bit of leeway. I've labeled the 2 wires that were connected and have marked on my diagram where those go, and so I think this one is good to go. I also did measure those resistors to make sure they were still good. They're supposedly 18 ohm. They all measured right around 20, so they're pretty close to their tolerance, and so that should work out fine. C202 is now wired in, and I think it'll fit there just fine. We got clearance, and we've got the 18 ohm resistors sitting around them here. I did notice something. Well, one thing, I had to replace this white wire. It was a little too short to come over here, and I also noticed this wire right here. This wire broke off of its solder joint. I don't know, it sure doesn't look like it was ever in there very good. So I'm going to run the new capacitor to that terminal and bridge this with a new wire. C202 is now wired into the circuit, and that looks like it should work fine there. Next, I'm going to tackle C203. That's this guy here. Now, this is a bank of 4 20 microfarad capacitors. We're going to replace those with 22 microfarad capacitors. They're kind of big, so I'm going to have to figure out how to best make this work in here with enough space, so let me give that a think. I think I can make this work. You can see I've already labeled the wires. that are coming off of this capacitor, and I think I can put 2 of them laying flat here just underneath the existing capacitor. I'll have a little bit more clearance because these lugs will be clipped shorter, and then the other 2 sections can go over here next to the transformer, and we'll just stack those on top of each other because they actually connect over here anyway, so that'll make them closer to where they're supposed to go. So that is the plan. By the way, I did measure the capacitance on the old capacitors, and while the values are pretty close, the equivalent series resistance is pretty high, much higher than the new capacitors. So, you know, while they might have worked, they're definitely getting leaky, and hopefully replacing them with the new ones will be a good thing. C203 is now mounted. So I put part of it here, right on top of where the old capacitor was, and I put the other part over here, which stacks up very nicely there. Again, it's only got one connection. These 2 capacitors are connected in parallel, and it's just connected over here. The last of the electrolytic can capacitors is C201, which consists of 2 of the 20 microfarad at 450 volt, just like we did on C203, and 2 of these little guys, 225 microfarad at 25 volt. And so those have to go here. And I think there's room to make that work. I'll put the big ones probably in this corner here, where I'm pointing, in this corner here, and the little ones can go anywhere because they're not very big. So that's the next step, making progress. I've got C201 cleaned up here. The resistors that are attached to it measured just fine, so I can reuse those. I thought I would show you the capacitor measurement though, and it's probably a very good thing that we're replacing this one, because let me show you. Where's my other end of my probe? Here it is. So I've got one end of my capacitor tester hooked up to the negative terminals for all of these, and let's just measure what we got here. So this one should be one of the 20 microfarad at 450 volts. And we get 24 ESRs, a little on the high side. The new capacitors measure right about 1 ohm. This is also the other 20 microfarad, and we get 3 ohms. Again, not a good ESR. And these other 2 terminals are the 25 microfarad at 25 volt, and they're not so good at all. Way out of spec, very high ESR. Same for the other one. Yeah, that's not good. So it's a good thing that we are replacing these. Well, capacitor C201 is installed. I think that will work pretty good. I've got the 2 bigger electrolytics right here. Once everything's done, I'll put a little bit of silicon underneath that. And then the 2 smaller electrolytics are right here with their resistors to ground. So I think we are done with the electrolytics. Now it's time to replace all of these film capacitors. And we've got bags and bags of those, so that's going to be our next step. Actually, the next step before we do all of the coupling capacitors is to replace the bridge rectifier, which right now is a selenium rectifier. So we're going to replace that with a more modern, and then a dropping resistor to go along with that, because the voltage will be a little bit higher with the modern rectifier. And then we're also going to add a thermistor that will help we'll put that on the back of the fuse, and that will slow the inrush of current a bit to help keep things going. Don't know if you can see it very well, but that's the selenium rectifier down there, and it's held on with a clip. So I'm hoping we can remove this clip pretty easily and get that off and mount in the new one. I managed to pry that clamp off that was holding the old rectifier in there, the selenium rectifier. basically I just wound up cutting off the tabs that were holding the ends in here. Get my pointer in here, here, and here. In fact, see a little piece of it still sticking in there. So it's marked. You can see, get the reflection right here. We've got two terminals that are the AC in, and then we've got a positive lead going out and a negative lead going out. And the new piece has similar markings on it. They're on the side that we won't see once we mount it, but we've got there we go, plus, minus, and the two AC inputs. So we just need to transfer these wires over, and the kit comes with mounting hardware, and so I'll be able to mount that in place of the old one. Probably put a dab of heat sink compound behind there as well. The new rectifier is installed. The hardware that came in the kit wasn't quite long enough, so I had some hardware handy, and also put a dab of heatsink compound behind that. So the next step is to install this thermistor. The instructions with the kit suggest mounting it at the back of the fuse holder. There's not a lot of room there, so I identified which line comes over to the on-off switch on the back of the volume pot right here, and I put a mark on that. So we're going to mount it here, which is actually what they did in the Blueglow Electronics video. There's a little bit more space there, so it'll have a little more air to help keep it cool. And again, its purpose is to limit the inrush current when you turn the amp on. The thermistor has been installed on the back of the volume pot. It's in line with the AC voltage that comes in from the back of the fuse holder. Next up, we need to install a new dropping resistor. So right now, there it is. Right now we have a 10 ohm 2 watt resistor, and the instructions want us to replace that with a 33 ohm 3 watt resistor, and we will do that now. Again, this is to help with the fact that the silicon rectifier will put out a higher voltage than the original selenium rectifier. And I should point out that the instructions with the kit call that resistor R106. It's not R106. It's actually R210. It is right here. This one comes right off the negative side of the new rectifier. The 10 ohm dropping resistor has been replaced with a 33 ohm resistor, and that completes this step of the instructions. Now it's time to replace a whole bunch of coupling capacitors, and this breaks it down in the kit. The different capacitors are sorted into different bags to make it relatively easy. For example, this is bag 3, which is the first one. We've got a bunch of the coupling capacitors. We've got a couple of electrolytics to replace, and the instructions will point out which ones to do in which order. Some of these will be a little bit tricky to dig out, but all of these capacitors are smaller than the originals, so that should help. And I'll maybe provide in this video a clip of me doing at least one of them. I won't bore you with showing you the video of replacing all of these guys. I have installed 2 of these film capacitors. I'm going to do these 2 next, and I'll show you this one. Hopefully you can see it between one of these 2 cameras, at least the way I like to do it. There's a lot of ways you can do this, but what I basically want to do is just clip out the old one. We'll clip him out, and then we'll solder in the new one. Alright, old one is out, and here's the new ones. And so one way to do this, especially when you've got the space, is just bend the terminal a bit, and then we're going to heat up the connection here, and I will be able to slide this right through. Try to keep my head out of the way of the video here. So let's heat you up. once that solder melts, I should be able to slide this right in like that to about there. We'll let that set. Of course, it's a cold solder joint, but we'll come back and fix that. And then on this end, we're just going to wrap this around this terminal. And if I can thread it through here, we'll get a nice tight connection. Loop you through this resistor, up around. And then I can wrap it around this terminal. And we can solder that. We'll give it a nice tight pull. Twist it around and crimp it down, and then we can solder both ends. This end will loop around the terminal also. So we get a good connection. Crimp that down like so. Alright, then we just have to solder it. And these are big lugs. Takes a little bit to heat them up, and you can flow a lot of solder onto these guys. Make sure it goes all the way onto both sides of the leads, and we'll do this side also. There we go. And then we just have to clip off the excess leads. So as much as I can for the rest of them, that's how I will do it. Some of them there's not as much space, so we may have to do the J-hook method, but it's nice again that these capacitors are smaller than the originals. All of the capacitors in bag number 3 have now been installed, and that are these 4, these guys here, and these 2 little guys here that feed the balance control, and these electrolytics. Now the original electrolytics, there we go, were radial components, so their leads went right across here. These of course are not, but since it's in parallel with these resistors, it's pretty easy to just wrap around the resistor and get those into place. Also, the kit replaced the 4.4 microfarad capacitors with 10 microfarad capacitors. In theory, that's supposed to be a good thing. All right, next up are some more of these film capacitors. In bag number 4, we have the parts for the phono stage, and that includes some capacitors. This is the phono stage here, and we'll also replace and upgrade some of the resistors in this stage. All of the phono preamp parts have now been replaced. So that is these 4 capacitors and these little tiny, you can barely see them, these little tiny resistors replace the ones that were there. These are the parts that came out of the phono preamp. So next up are the tone control capacitors, and that's these guys right here, and that's bag number 5 in the kit. The 4 tone control capacitors have been replaced. That was these ones here. And now the next step is just some remaining capacitors. And that is bag number 6 in the kit. So let's do those now. Bag number 6 includes the remaining 4 film capacitors, the one electrolytic capacitor that's left to be replaced, and an extra fuse. The last two film capacitors here and here, well, at least these bigger ones, have been replaced. And also the electrolytic here. Of course, again, I had to bridge the leads there a little bit. I put some insulation on the wires there just to make sure everything is protected, and it just reaches. So that replaces the 50 microfarad capacitor that was there. And just for grins, I want to test the old capacitor because I wasn't able to test it in circuit. Yeah, this capacitor tests high with not a great ESR, so the new one was much better. These last two film capacitors are going to be a little tricky. I'm going to have to flip this unit back over. They are attached onto the loudness controls. So it's those two capacitors right there. A little bit easier access from this side. You might remember at the beginning of this video I mentioned that this compensator switch was broken. The little knobby is broken off. I have a replacement, and it's that same switch that these capacitors are mounted to. So I might as well do the switch and these capacitors at the same time. This is the replacement that I found on eBay with these switches. If anybody needs some of these switches, maybe let me know. But I'm going to take this one off. I'll have to drill out the rivets here, remove the switch, and then do the same for this. But in order to do that, I have to remove the faceplate and the knobs. The replacement switch has been liberated from that donor front panel, and I have now drilled out the rivets that held in the switch that we need to replace, and I made myself a drawing of where all of the various connections go. So now it's time to move the wires and swap it over. All right, that section is completed. It's a little tricky. Of course, normally you probably wouldn't have to be replacing this switch, so that made it a little trickier. Definitely want to have a drawing to show what goes where. Take pictures. Even though I was pretty diligent, or several times I'm like, okay, does this go to the front or the back of the potentiometer down there? While I was in here too, I'm also going to go ahead and deoxit clean these controls. I've reflowed a bunch of the solder joints on the various connections that looked a little bit dry, and so now we're ready to start to put it back together and test it out. There's just a few more things I want to do before I power this up and test it. First thing I'm going to do is use a Dremel with a little brush on it to clean up the connectors back here. I removed all the screws. We'll clean those, polish them up a little bit. Same with all of these RCA jacks. And then I'll put a little bit of deoxit on those as well to help keep those protected. So yeah, I'm just very gently brushing those to get the tarnish off, and like I said, we'll put a little deoxit on those after too to help protect them. And then I'll do the same on each of the screws. This is the deoxit that I'm using. It's just the straight D100. Comes with a brush, but I also have this little kind of dental brush. If I get that to focus on there. This will fit perfectly down into the tube sockets, so I can get some deoxit down in those as well. Yeah, this little brush is like the perfect size to get down inside these tube sockets. Just kind of push it in there and twist it around with a little bit of deoxit on it. So all the tube sockets have now been cleaned with deoxit, as have the terminals on the back. And so now I think it's time to put the tubes back in and button it up and turn it on and see what happens. I'm just about ready to apply power for the first time. I've got my test equipment set up. We've got a 100 watt 8 ohm dummy load that we'll use until we are ready to hook up speakers. I have glued down these electrolytic capacitors that I replaced. That's just holding that one down until the silicon sets. I've got the scope ready to go. We've got our isolation transformer, variac, and just to be on the safe side, a dim bulb tester. Alright, well, I believe we are ready to power it up. I've got my voltmeter back there set to monitor the voltage on pin 7 of the output tubes. I'm following the directions from the refurbishment kit. There are also some power-up instructions from the original assembly manual, but I'm assuming, since this worked before, I'm just going to start with the dim bulb and the variac. What I've got is my isolation transformer in the background connected to the variac, then connected to the dim bulb, and the dim bulb output is connected to the Scott. I also have a volt amp meter that the amp is plugged into, so we can monitor what's going on there. So I'm going to bring up the voltage slowly. I have removed the output tubes per the instructions. All the other tubes are in place. I've dimmed the lights a little bit, so hopefully we can see what's going to happen here. So I'm going to power on the variac. It's set at about 40 volts. So right now we have 37 volts going into the amp. Nothing dramatic is happening at this point. No real power draw that I can see. I guess I should turn it on. That would probably make a difference, huh? So let's turn it on. And it's on. We see it's beginning to draw some power a little bit. The dim bulb is on. Let's bring the voltage up. Okay, I'm going to pause this and bring up the voltage a little more, and we'll see if anything is powering up. Well, Houston, we have a problem. It is drawing way too much current. I've done a little bit of troubleshooting in the interim since that last segment during the first turn on, and I fear the problem may be with the main power transformer. So I've done some measurements. Let me show you what I'm seeing here. It's just drawing way too much current. Let me go ahead and turn it on. That power up blew the fuse, which was a 3 amp fuse. I have temporarily put a 7 amp fuse in there, and let me demonstrate the issue here. So I've lowered the variac voltage down to 40 volts. We'll turn the amp on, and you'll see what's going to happen here. We're just drawing too much current. Right now we're drawing 3.8 amps, 151 watts. The unit has no tubes in it. The maximum power draw, according to the schematic, shouldn't be more than a couple hundred watts. Right now, like I said, we're pulling in 4 amps, and what's going to happen is the power transformer here is going to start to get really, really warm. So I'm a little bit concerned that there's something up with the main high voltage winding on this transformer. What I want to do is isolate it and remove these other sections here, so that the only thing being powered up is here. This tube is not inserted right now, so there shouldn't really be any load on the primary high voltage section of this transformer. These other sections are lower voltage. This 50 volt AC feeds the bridge rectifier, and then these other sections just feed filaments. So let me do a little bit of isolating here. I also did some ohm measurements on those coils, and they're not balanced, which I think they should be, since they're both supposed to max out at 360 volts across that center tap. I clipped off this section of the primary power transformer that's feeding the bridge rectifier, and let's go ahead and turn the unit back on and see what happens with that section removed. And we're still drawing too much current. 200 watts with nothing, no load really. So it's nothing to do with that section. I now isolated this section of the filaments. So this section of the transformer is now open. This section of the transformer is now open. This section feeding this part is open because there's no tube there. And the only thing connected is the high voltage section. And we still have the problem. So I just turned it on. And you'll see we start drawing an awful lot of current. And the only thing connected in the circuit now is this transformer. So my conclusion at this point is we've got a problem with this transformer. I'll do a little bit more digging, but I need to talk to the owner now and see what he would like to do. I have now isolated all of these transformer outputs, so there is nothing in the circuitry that's connected to the transformer. And when we turn the power on, we still get an enormous power draw. 5 amps, yeah, 240 watts with nothing connected. So yeah, and the transformer will get hot. So I'm guessing there's probably a shorted winding in there. That's unfortunate. I'm not sure if that's a part I would be able to find. Time to do some research, I suppose. I thought I would pull out the thermal imaging camera, and I'm aiming there at the transformer, and you can see I've had it on for about a couple minutes now, and it's already pushing 150 degrees. It's a lot of current draw, and the other really hot spot right there, that's the thermistor, the inrush current limiter. We're drawing in 3.3 amps right now with the voltage set at 50 volts. So that's not good, not good. I spoke with the owner and got the green light to go ahead and have the transformer, the power transformer, rewound. There's a fella down in California that does that, and so I'm going to remove the transformer and we'll move forward from there. Alright, the transformer has been removed. I'm going to box it up and ship it off and hopefully get it repaired. I will conclude this as part 1. It'll probably be 3 or 4 weeks until I get the replacement or the refurbished transformer back, and then we'll continue on with part 2 and hopefully get this amplifier to sing some beautiful music.